So friends, we are solving the Hackerrank linked list module. So this is the new question which is given as inserting a node into the sorted doubly linked list. So let's say we have been given a doubly linked list wherein we have to insert a node uh, at the appropriate position. So this question will have so many cases. Let's say this is the linked list given to us, and in this linked list we have to insert, let's say, the node 4. So for insertion of this node, I'll take the two pointer concept wherein there is a p which is at the first node in the linked list and q is null. So q will always be the previous node of p. If x is greater than the information of the current node p, I'll update this q to the node where p is there and p at the next node. X is again greater than the data value of this p node. So I'll once again update this q and p. Q will always remain previous of p. Now I have this x equals to 4, which is again greater than the information of p node. So I'll once again update this q here and p here. Now in this case, x is not greater than the information of this p node. Hence the node x will be inserted, or node containing the data value x will be inserted after q. So if I have to insert this node after q, in that case, I'll create a node. Let's say the node created is s, containing the data value 4. Let's simply create a node which is having the data value 4. And in this case, let's say this node is s, then the previous of x will point to q and the next of q will point to s. Next of s will point to p and previous of p will point to s. Something like this. So this way the node can be inserted in between q and p. So here what we are actually performing, we are actually inserting after q. So let's take another case which will make the other cases very clear to you. Let's say we have 1, 2, 3 and 4, and the data value which is to be inserted is, let's say, 7. In that case, let's take p to point at the first node and q is null. 7 is greater than 1, so p and q will progress to the next node. 7 is greater than 2, so once again I'll update this q and p to the next nodes. 7 is greater than 3, so once again this will be updated. 7 is greater than 4, hence q will come here and p will come to the next node. The moment you increment this p to the next node, p will become null. So this should be the stopping condition for us, that if p is null, we have to stop. After this node with the data value 7 has to be inserted. So let's take a node s which contains the data value 7. So as we did earlier, the next field of q will point to p and previous field of p will point to q. Then the next field of s will point to p. By that way, the next field of s will become null. But since p is null, we cannot set the previous of p as we did here. So the previous of p was set at s, but since p has become null, we should not do that. So we have seen this case also. Now let's say the data values of the nodes are 10, 15 and 20, and now I have to insert 5 in this linked list. So if I have to insert this 5 in this linked list, in that case, I will have to insert at the beginning. So let's see how will that happen. So let's initialize this p at the first node and q is null. And when I make the traversal, this x is not greater than p. So my traversal will stop here. When I'll see that the q is null, that is an indication that I have to insert this node containing information 5 at the beginning of the linked list. So for the insertion of the node at the beginning of the linked list, let's say this node is x, s with containing data value x. I'll say that the next field of s will point to p and the previous field of p will point to s. The previous field of s will be null, and since this is the new node, so head should point here. So I think I have discussed all the cases here. and we will incorporate those things in the code. Let's look at the code. So here is the code given. We have to insert in the sorted doubly linked list. So this is the function which was given. list is the address of the first node and the data is the value to be inserted. So from our side, I have taken 4 pointers p, q, r, and s. The new node is created using the malloc function. The data of that node is set as data. Its previous and the next fields have been set as null. Now, while p is not null and data is greater than or equal to p dot data, it means we are comparing the value which is to be inserted with the data value of p. If the data is greater than or equal to that, I am updating this q and p simultaneously. Q will always remain the previous node of p. If p is null, it means p has crossed the last node, or data is not greater than or equal to the data value of p node. It means here is the time for the insertion. After this, if q is null, it means that we have to insert as the first node. So s dot next equals to p, it means the newly created node s will point to the first node. Means the next field of the newly created node will point to the first node. I already have taken the example of this. Let's say this was the linked list 10, 15, and 20, and the data value 5 had to be inserted. So this was the S node. Here we are saying that the next field of this node will point to the first node, that is P. If P is not null, it means we did not have the nodes from the beginning. The head was null or list was null. It means this is the first node to be inserted. In that case, we should not make any change to the previous field of P because P is already null. But in case the linked list is existing, and this is the case, then this node will have a previous field, and the previous field of this node should point to S. So if P is not null, then P dot previous is equals to S. And since the linked list has changed, this should be the new first node. So L list is equals to S. If Q is not null, then I have to insert somewhere in between. So this also I have taken an example. Let's take it once again. Let's take the example once again. Let's say there are two cases. Let's say this last node is 9 and we have to insert this 4. So for this, Q will be here and P will be here. And the new node is S. Here we have inserted the data item 4. So what I'm saying that the Q dot next equals to S means the next field of Q will point to this S. Previous field of S will point to Q. Next field of S will point to P. And the previous field of P will point to S. But this has to be conditional, because if I have the linked list like this and we have to insert nodes with data value 7, this will be Q, and by that time P must have become null. So if I go one by one, the statement number 1 says that Q dot next equals to S. Statement number 2 says that S dot previous is equals to Q. Statement number 3 says that S dot next equals to P. So P has become null, so the next field of S will also become null. Statement number 4 is a conditional one. Since P has become null, this will not work. It means that we should not set the previous of P because P has already become null. So this way, this code has been written, and finally we are returning the address of the first node. Let's run this code. So you can see that the sample test cases have got passed and all other test cases have also got passed. So thanks for watching this video.